Hello class, we will start the chapter number 2, polynomial. Already we started. We'll see the next topic related to the relationship between zeros and coefficient of a polynomial. As you know, in case of quadratic polynomial, we can have at max 2 zeros. Considering that 2 zeros are alpha and beta. So we have to verify two types of relationship. One is product of zeros, that is alpha into beta, and before that we will see the sum of zeros also, sum of zeros, that is alpha plus beta. So we are going to talk about the two different types of relationship, that is sum of the zeros and product of zeros. But before start with the relationship, we will see how to find out the zeros of quadratic polynomial. I'll take one example to explain the topic, how to find out zeros of polynomial. Let me take one example. Suppose we have a polynomial px is equal to x square minus 5x plus 6. One of the simplest example I am taking so you can understand very easily. X square minus 5x plus 6. As we know, very basic things related to zeros of polynomial, how to start with that. In 9th standard, already you did the very first step, whatever polynomial is given, equate as 0. So let me equate the given expression as 0. X square minus 5x plus 6 is equal to 0. Very first step. After that, let us try to do factorization of the given expression, that is x square minus 5x plus 6. Very simple step. What we need to follow? You need to take 6 outside. You can do the rough work and write all possible factors of 6, like 1 into 6, 2 into 3, 3 into 2, 6 into 1. Out of this 4, we can have 3 into 2, 2 into 3 same, so we can take any one. Same way 1 into 6 or 6 into 1, both we can consider as 1, so we can remove any one. Out of this 2 now, we have to take any one in such a way, as you know everyone how to do factorization. I'm just revising the things so those who has forgot so they can understand again. Out of this 2, we have to take any one in such a way, after addition, it should come minus 5. As we know, whenever we are doing the middle term splitting, we have to think in that way only. The last term is positive, means we have to take any one in such a way, after addition, it should come minus 5. So we can take the second part, that is minus 2 minus 3 is equal to minus 5. So let us split this middle term, that is minus 5x, in the form of minus 2x minus 3x. So x square minus 2x minus 3x plus 6 is equal to 0. It is not mandatory to take minus 2 before. You can take minus 3x here or minus 2x that side also. It's our choice. Of course, when we will split, we will get the 4 terms. Make the pairing of two terms and take out the common. So we will take x common. So x minus 2. Minus 3 is common. So x minus 2. Of course, we got the 2 terms now in which x minus 2 is further common. Let me take x minus 2 again common. So we will left with x minus 3 in another bracket. So this is very simple factorization which we have done over here. We studied in the 9th standard. So we got 2 terms, right? X minus 2 and x minus 3. Let me explain very basic thing what we have to do further. I'm taking 2 numbers, a and b, everyone. Try to understand, and product is 0. A into b is equal to 0. Let us think when the product will be 0. Of course, anyone has to be 0. I mean, either a has to be 0 or b has to be 0. Then only the product will be 0. Based on this concept, let us equate both one as 0. It means that we can take x minus 2 as 0 and x minus 3 as 0 and solve for x. So x will be equal to here 2 and here x will be equal to 3. Correct? So we got the 2 zeros. As in the very beginning we have discussed that we need to represent these zeros by using certain symbols. So let me write these 2 zeros as alpha and beta. These are all of the symbols we can represent to show the zeros, alpha and beta. And it is not at all mandatory, everyone, that we have to take smaller one alpha or greater one as a beta. You can take anyone as alpha or anyone as a beta. It's our choice. Moving ahead, we have solved this quadratic polynomial to get the zeros of the polynomial. Now, we will discuss how to find out the relationship. As in the very beginning I told, we have to discuss two types of relationship. One is sum of zeros and second one is product of zeros. Let us discuss that. Let me take the polynomial again, everyone. Just observe carefully. That is x square minus 5x plus 6. We know the standard form of polynomial, quadratic polynomial, is ax square plus bx plus c, where of course a is not equal to 0 and a, b, c are the constant. Basically a, b, c are the constant we used to call as arbitrary constant, because actually we don't know what values they have. So we used to call as arbitrary constant. A is not equal to 0, already we discussed, because if a will be equal to 0, it will convert to linear polynomial. Now, if we compare the given polynomial which we have taken as example, x square minus 5x plus 6, with the standard form of the quadratic polynomial, we will get the values of a as 1, b as minus 5 and constant c as 6. Right? We need to write all three values. Let us talk about the relations now. So let me do the sum of zeros, that is 1 plus minus 5, that is minus 4. Am I clear, everyone? 1 plus, I'm sorry, I did mistake. We have the zeros as 2 and 3. So sum of zeros will be 2 plus 3, that is 5. Now, observe very carefully with the coefficient, everyone. Can we write sum of zeros alpha plus beta is equal to, if you observe very carefully over here, can we write minus 5 upon 1? Instead of 5, can we write minus 5 upon 1? We can write, of course. And observe these values a, b and c. So we can write minus b upon a. If you'll see very carefully, the value of b is minus 5. So we can write minus b upon a. And this is one of the relation which we can write in the form of formula, that is alpha plus beta is equal to minus b upon a. Let us go for the product of zeros. I'm writing here product of zeros. We have our zeros as alpha and beta 2 and 3. So let me multiply 2 and 3, which is equal to 6. Now observe the values. I'm writing alpha into beta as a product of 0. Can we write c upon a? Means 6 upon 1, that is c upon a. So this is another formula. Product of zeros will be c upon a. So we got the two relationship, everyone, in the form of formula, and the relation with the coefficient also. That is alpha plus beta is equal to minus b by a. Alpha into beta is equal to c by a. Now what type of question will be asked to us? Let me take one example. Again we will talk about that. We have to remember two things, everyone. Alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Alpha plus beta is equal to minus, b means coefficient of x and a means coefficient of x square. So we can say alpha plus beta is equal to minus coefficient of x divided by coefficient of x square. Same way here also, product of zeros, alpha into beta is equal to constant upon coefficient of x square. As I said, let us talk in what way question will be asked to us. So again I'll take one simple example. Question will be ask you in the way that find the zeros of given polynomial and verify the relationship between them. I'll take very simple example. Suppose I'm taking one example, px is equal to, very simple example, x square minus x minus 6. What way question will be asked? They will ask us find the zeros of given polynomial and verify the relationship between zeros and coefficient of it. Same process we will start, everyone. Very first step, we will try to find out the zeros of polynomial, and the first step is equate as 0. So let me take x square minus x minus 6 equal to 0. As we know, we need to write all possible factors of 6, which is 1 into 6, 2 into 3. But this time we have to be very much careful about it. The last sign is your minus, that is minus 6, means among these factors we have to do subtraction. After subtraction, we have to come with minus 1. So what we can do, everyone? We can simply do 2 minus 3, which is equal to minus 1. It means that this minus x we can split in the two terms, that is plus 2x minus 3x. So let us do that. That is x square minus 3x you can take first, and 2 plus 2 you can take afterwards. It's your choice. So minus 3x plus 2x minus 6 equal to 0, or plus 2x minus 3x. It's our choice. Take the pairing and take the common again. So x minus 3 plus 2 x minus 3 is equal to 0. Again x minus 3 will be common, and x plus 2, which is equal to 0. As we know, if the product of two numbers is equal to 0, means either one has to be equal to 0. So first one, that is x minus 3 is equal to 0, or x plus 2 is equal to 0. So x will be equal to 3, this is 1 0, and x will be equal to minus 2, second 0. We can mark any one as alpha and beta, it's our choice. Let me mark this as alpha and this as beta. Now, first part is done. As instruction is find the zeros of polynomial, we already did, alpha and beta we got. Second instruction is to verify the relationship between the zeros and coefficient of the given polynomial. So let us talk about the second part, everyone. Before start with the verification, everyone, it is mandatory to have the values of coefficient, that is the values of a, b and c. So what we will do, we will compare the given polynomial with the standard form, that is px equal to ax square plus bx plus c. Of course, a is not equal to 0. We will compare with the given polynomial. We can have a is equal to 1, b is equal to minus 1, and c is equal to minus 6. Now, for the verification, everyone, we have to do two types of verification, as I already mentioned. One is sum of the zeros and one is product of the zero. For the verification, what we need to follow? You need to do 2 times or addition and 2 times or product. How we will do? First time we will do the addition, means sum of the zero manually. So we will write sum of zeros. So let us take 3 plus minus 2, which is equal to 1. We did manually. Now, as we know, we have the formula to find out the sum of the zeros, that is alpha plus beta. So let us take alpha plus beta is equal to minus b by a, and we have the value of b as minus 1. Minus is already in the formula, divided by a, that is 1. So we got 1 upon 1, which is equal to 1. So both are same. Means we can say sum of the zero is verified. Second part, product of 0. Again we will multiply manually. First of all, product of zeros. That is, we have our zeros as 2, 3 and minus 2. So 3 into minus 2, which is equal to minus 6. Again by the formula, that is alpha into beta, that is c upon a, constant upon a. So we have constant as minus 6, a is your 1, that is minus 6. So we verify the product also. At last we will write verified. So let me recap again, everyone. Question will be asked you in the form of find the zeros of the polynomial and verify the relationship between zeros and coefficient of it. So first step, we have to find out the zeros. Either one will be the alpha or beta, it's our choice. And this is the process, we have to verify it. So for that, we need to find out the values of a, b and c. Manually we have to add, and second time we have to add by the formula. Both has to be matched. It is matched over here in this example. Same way we have to do the manual product, which we got minus 6, and by the formula, that is c upon a, and both has to be matched again, and both sum of the zeros and product of zeros are matching, and we will write the verified. Okay. Now one more formula we have to discuss in the next class based on if zeros of the polynomial is given it to us, or sum of the zeros of polynomial and product of zeros of polynomial is given it to us, then how to find out the quadratic polynomial. Thank you.
I have a question, sir.